Let's look at OpenStack's College Physics Chapter 9, Problem 32. Even when the head is held erect, as in the figure, its center of mass is not directly over the principal point of support, the atlanto-occipital joint. The muscles at the back of the neck should therefore exert a force to keep the head erect. That is why your head falls forward when you fall asleep in class or when you watch my videos. Calculate the force exerted by these muscles using the information in the figure, and what is the force exerted by the pivot on the head. All right, let's get organized. So we know a few things in the diagram. So I'm going to call the distance here, let's point to it. So this distance here, I'm going to call L1, and I'm going to call that distance over there L2. So I'll write it as small as I can here, L1 and L2. So basically what I have is L1 is 5 centimeters and L2 is 2.5 centimeters. Then I'm told that the weight of the head is 50 newtons. And there are two other forces acting there, the force at the pivot and the force over here, and we don't know what these two forces are. So we're going to try to calculate them. I'm going to redraw this and just make the forces a little bit more clear. So I have a center of gravity up here. This is where the weight is. I have the pivot over there, and this force is the force of the joint. And then the force of the muscle goes down this way, and that's F sub m. They're all vectors, so let's put the vector symbol over them. All right, so this is a little bit clearer. We know that this is L1 and this is L2 over here. All right, so we know a few quantities. We're looking for, in part A, the force exerted by the muscles, so we want F sub m. And in part B, we're looking at the force exerted by the pivot on the head, so we want F sub j. All right, so since the head right now is in equilibrium, that means that some of the forces on the head is 0 and also some of the torques is 0. So I'll have some of the forces in the x direction is 0, some of the forces in the y direction is 0, and some of the torques is 0. Well, luckily in this problem we have no forces in the x direction, so this equation won't tell us anything. In the y direction we have three forces. We have one going up, and that's F sub j, and we have two going down, that's the weight and the force of the muscle, so sum of these three forces is 0. Well, this equation is not very helpful because I have two unknowns. So how about we write the equation for the torque, and the best place to pick a pivot is where there is an unknown force. So I don't know this force Fj, so I'm going to pick this as my pivot. Then the torques that I'm dealing with are going to be the torque due to F sub m and the torque due to the weight, and there is no torque due to F sub j because F sub j acts right at this axis of rotation, so the lever arm is 0. So I will have to figure out directions for my torques. If the only force that were acting were F sub m, then it would give the head counterclockwise rotation, so that's counterclockwise, which by convention is a positive torque. If the only force that were acting were the weight of the head would droop forward in a clockwise rotation, so that would be a negative torque. So remember that torque is force times lever arm times the sine of the angle between them, and I'm going to start out with force of the muscles, so that's F sub m. Lever arm is the distance from where the muscle acts to the pivot, and I want the distance that's perpendicular, so the force here and the lever arm are already perpendicular. So I have Fm times L1 times sine of 90, which is 1, minus the weight times the lever arm. So if we look at this problem, we'll see that the point where the weight acts, the center of gravity, is up here. So the lever arm you can consider to be the distance from the axis of rotation, our pivot, and the center of gravity. But we need the perpendicular component, and we already have a perpendicular component here, so we don't have to mess around with angles anymore. So we just multiply the weight of the head to this lever arm, the perpendicular lever arm, to find the torque. So we have minus weight times L2, and those are the only two forces that cause a rotation about that pivot. So now we can solve for the force that the muscles exert. So that is Fm is weight times L2 over L1, and the weight is 50 newtons. L2, I'm going to leave my units in centimeters because they will cancel out anyhow. So that's 2.5 centimeters divided by 5 centimeters. So as I said, the units will cancel out, and we end up with 25 newtons. And since the value is positive, it means that the original direction that was chosen here was the correct direction. So that means that this force acts down. So now from the sum of the forces, we know that F sub j minus W minus F sub m is 0, which means that F sub j is weight plus F sub m, and that is 50 newtons plus 25 newtons, or 75 newtons. And again, we got a positive value, meaning that the F sub j that we calculated is going up in the positive direction.